Hi everyone, good morning, good afternoon, or good night. My name is Eduardo Camargo, and today we're going to talk about GitOps. This next session will walk us through implementing a successful GitOps strategy from the ground up. Our speaker, Juan Valencia, one of our senior DevOps engineers, will share how he helped build an everything as code setup while ensuring scalability, security, and portability of the application. But before we jump into the session, a very quick reminder, follow us on social media and check out other sessions of our Global Devweek. Use the chat to leave your comments and questions. And without further ado, take it away, Juan.
Hey, thank you very much. Okay, hey guys, I'm Juan Valencia and I'm senior DevOps here in Encora. And I will talk to you about some, these modern topics about Git and also DevOps combined in a full strategy so we can, work and automate everything to make our operational work easily and also make the developers happier in some way. Okay, so yeah, let's get started with this agenda. I have a short number of topics, but they will cover most of the things about the GitOps strategy. So, okay, so what is GitOps? Yeah, GitOps is it's a series of good practices and a methodology we can use to create and automate our operational work in DevOps side and also in the development side by simplifying processes and helping developers to focus on features and not in the infrastructure problems. That's basically my definition of GitOps, and you can find a lot of information in internet now. But basically, we can help everyone to be happy. Even the customer is going to be happy because they will have faster releases, more reliable ones, and also you can do any rollback very easily with these kind of strategies. So that's helping the business not to get stuck in a problem. Okay, so basically, the idea behind the GitOps is taking the DevSecOps operations into the next level, which is not having them separated. We can use automation to make these things, and we don't get stuck in, important things like security or any possible infrastructure problem, and those long hours of investigation when we are having some issues in production or any kind of release. We have everything tracked as code because we can use different tools that we have now for infrastructures. We can keep track of changes in the infrastructure via any kind of infrastructure code. We can improve collaboration so anyone can know through this code which things we have done in the infrastructure. We can enforce compliance as well because we can put the best practices on all of the things we do by enforcing security and different levels of security checks that we can do. And also compliance, it's going to help us to have a better and more reliable software delivered to the customers. And our Git repository will be the source of truth, where we can have everything put in, so we can just see the history of changes, and we can fix things quickly by having this history in Git. Okay. And okay, so some of the goals that I have in mind about the GitOps, right? It's keeping everything simple. We can provide easy processes to deploy infrastructure and also deploy applications via the Git repository platform that we could use. Also the pipelines or the mechanisms they provide to run pipelines. We will reduce dependencies because we don't need any group of engineers working in deployments, manual things, those things that get complicated everything and anytime we have an issue. And we have this history of changes, which is very important because we can track whatever the changes, whatever the possible problems. We can roll back quickly with this history. We can see if anyone missed something, any configuration, or even the developer will have an idea if the infrastructure is struggling because of one of the changes that the developer could push into the development side. There is more efficiency because we can make better decisions, implement better good practices to improve collaboration, And we can also, as I said in the beginning, a better developer experience, and they can focus on features instead of problems. We will have faster releases because the pipelines will help us to make things straightforward, and we can optimize it every time we see any pipeline struggling with something. We can do some optimization and getting better the process in the next time, right? And also the cost control, because as we have all of the source code of the Terraform or any kind of infrastructure as code that we use, we can see those infrastructure changes over there, so we can control whatever the resources are being used or not. We will have them tracked in the code as well. And also we can make changes faster and make it over the critical components without with a low risk. And yeah, just keep track of any change and anything that could just push the customer's wallet until the floor. So yeah, this cost control, which is also a good goal for GitOps. So for the next topic, it's some solutions I found. We can use different Git providers for this. We can use different ways to do it. There's no a formula itself that we need to implement or use, but we can also choose our own tools to get it done. So there are some kind of requirements, or they cannot be like this hard, but yeah, sometimes it helps to get a better GitOps strategy. So this will work better for containerized applications. We can do automated CI/CD for different environments. We will have a really better control of infrastructure changes, and we can implement better observability and monitoring which this also helps to control the system behavior, and also to fix and find any kind of issue, even security issues, very quickly. And this one is very important, the zero downtime deployments. All of the tools that we can find now on the internet to provision infrastructure or even deploy applications, they are focused on zero downtime deployments, which is something really important also for GitOps, because we can provide faster deployments, but with zero bad impact in the software development cycle. Security is also it also gets improved because we can choose different security level tools that we can implement in our pipelines in order to make the software secure, and also to get monitor security events and other things that we are not seeing once we are deploying, but they will be automatically detected for some of those tools. And as soon as we use more AWS managed services, in this case AWS, it's kind of uh, the cloud I have more experience in. But I can tell you that if you choose the right services and the managed ones, you will get into less trouble once you're deploying your applications. Okay, so this is one example of one of the most used, by me at least, tech stacks for GitOps. It's microservices architecture. It's a better example of those platforms that you can use to deploy this kind of automated GitOps applications. So in this case, I have used microservices with Java and other kind of a technology, but microservices is a good approach to use really fully the GitOps strategy. Any Git platform will help you. You can see different Git providers in the market, like Bitbucket, GitHub, or different ones, but they will also help you, anyone that you can choose. AWS in this case, for my experience, I used New Relic or CloudWatch or any other observability tool to implement also in this GitOps strategy. Argo CD or Flux, sorry, in the case of Kubernetes technologies, and also Docker containers and Kubernetes itself with EKS with Fargate, which is also one of those complex services, but it's managed by AWS, and it will help you to have less operative work on the infrastructure side because they take care of security stuff and different things from the service itself. This is one simple flow of one development CI/CD that is also a secondary or parallel part of the GitOps strategy, which is you have your application repository, you have a feature branch that you create from one of the main branches of your project. Then you have the pipeline, which is the very important part of the process. The pipeline takes care of the tasks, the main tasks of the building a container or building a service, and then you can push it into a ECR repository, in this case for EKS, or any other kind of a Docker repository like Docker IO. And Argo CD is a tool that automates the delivery or deployment of the software to the Kubernetes cluster. In this case, is illustrated by the EKS cluster with Fargate. And the changes that are pushed into the ECR are also reflected in a infrastructure as code repository, where it can track the new version of the Docker image that is pushed to the ECR, and then Argo CD will take care of the deployment. For some of the implementations I have done, I have used also Argo rollouts, which is a tool that helps you to make the zero downtime deployments. So it's a complement for Argo CD, and it's pretty effective, and it has been working pretty fine for me in my projects. And this would be, this is an example of one GitOps architecture using GitHub, for example. You have your YAML manifest with the configurations and anything that you can use for your deployment in the GitOps. And you can, in this case, for example, we're using Jenkins. So we can have Jenkins as a builder of the Docker images, and also ECR again as the image repository. And as you can see there, there's also EKS for managing the Kubernetes things. And yeah, this is one example. This is another example, which the basic stuff about having the developer creating different branches for different projects for different technologies. And there's also one process for continuous integration, build and push for the containers. This will be like the general example of the GitOps architecture. And we have Flux in this case to deploy, to make the deployment in the Kubernetes cluster. This is another one using AWS tools. We have here a code commit, a code pipeline, and code build, and also Argo CD. So the combination of technologies that you can use, is unlimited. So you just need to take the tool and start, building your own GitOps strategy by using the right tool. There's no limitations, because the only limitation is the one that you can just push in because of the software, or something that is not helping you at all. But you can also find something like Jenkins that is always a good tool to do custom things if you require anything very specific. Okay, so now infrastructure as code is a really important part of all of these things, because the infrastructure side, it will be implemented by Terraform or any other infrastructure as code tool or language. So you don't need to change anything manually on your cloud, and you will keep the same track of the changes and the history of things that you have been done with your team, and all along the infrastructure implementation. And you have these advantages by using infrastructure as code: flexibility. You can deploy any infrastructure component available by the provider. In this case, Terraform have different and many providers like Azure, AWS, and Google Cloud as the main examples, but they have many things. You can also deploy New Relic things, or different stuff from different providers. So it will help you to automate anything from your infrastructure side. There's portability. You can run the same Terraform code or any other infrastructure as code in different Git pipelines. As soon as the provider is available, you will be able to to take your Terraform code or any other infrastructure as code to the different providers. And it is collaborative because you have it in Git, right? So you can just make your DevOps or your DevSecOps guys to participate in the same project at the same time by any Git strategy that you can implement. So you can also review the pull request the same way as you do in a development, in a software, but you can do it in the infrastructure as well. So different pairs of eyes can take a look on your changes and prevent any kind of issue, or even collaborate with you to improve your work. Or you can show your partners or your teammates different practices, right, in the infrastructure via the Terraform code or the infrastructure code. So next topic is security. It's just a little bit because security it's very extended and high end topic, but I will try just to show you what is the things I have used in GitOps about security. First, the static application security testing, which is one important thing I have implemented in pipelines, because you can automate this and just detect any possible bug or vulnerabilities in the source code before it gets merged into the main branches and pushed to production, right? So we can just take advantage of this and detect any kind of problem that we could have in our application once it is deployed. ECR image scan, it's very important because apart from the software vulnerabilities, we can have vulnerabilities in the Docker side, for example. If we detect this soon, we can avoid the introduction of any vulnerabilities about the Docker layers or images that we are using for our implementation. And we also can find out problems with dependencies and CVEs and anything related to security about the image that we are using for the Docker or any other kind of containerized technology. And also, at least in the projects I've been working on, we do a security audit very frequently, so we can detect before it happens anything bad. We can detect problems in the infrastructure or the development side by doing some extensive security checks that collaboratively we kind of check everything point by point and just help to point out and fix those issues before they go to production. Right after even SAST or ECR image scan, we do this kind of manual checks to make sure that everything is going fine and secure. And also about AWS security things that they provide us as service. We usually use enable the advanced shield, which helps you to prevent any kind of DDoS attack or any other kind of a perimetral attack. And they have very good support for us in the security side. And anytime we detect something, it is pretty straightforward to stop those attacks to go and into the infrastructure before they cause any damage. Usually, I recommend to use the WAF because you can control different things before they go into the application and they do some damage on the application itself or the infrastructure itself. We can prevent and create rules specifically for any special case, or we can use the managed rules from AWS, and they prevent bot actions, for example, or side of software scan, different things that we can prevent with WAF. We use usually EKS cluster encryption, which is also good to prevent any kind of security issues with the transport of the EKS cluster administration or information itself from the cluster. And closing the IPs, it's a really good practice that all of the tutorials and things that you find on the internet, they don't point into this. But definitely closing the management of the cluster to known IPs or VPN, whatever, the mechanism that we use with the project. It's a really good practice that we need to take in mind every time. And also making the lower environments private, it's a good practice. At least for me, it has been helping to prevent any kind of information leakage or whatever the things that we can just uh, we are not seeing because we think that the private environment, the lower environment is not getting accessed by anyone. But we should definitely make sure that we are not allowing anyone from the outside to see our lower environments by protecting them via VPN or security group or whatever the mechanism we want. But it's really important to have it protected. Okay, so I'm going now into my conclusions from the GitOps strategies and DevSecOps and everything I have talked about. Okay, so for me, agility, automation, and collaboration, they are kind of the three and the most important things that GitOps it's providing. Because we can provide more and rich development experiences to our developers teams. We also provide more agility to the customer because we can deliver faster, we can deliver secure software, and definitely the automation helps a lot because we are reducing all of those things that we do manually. We can perform and improve our practices by just doing repetitive tasks into processes, and the development cycle will be healthy definitely because we are just going through these iterations anytime we see something that we can automate or improve. And the collaboration is also a really good thing because all of the things that others know we can show to other probably junior members or anyone in the team, and we will learn in a collaborative way because everyone will show their own qualities or knowledge about things in the Terraform code, for example, or in other things that they also put into code. So this increases the quality in all of the aspects of the delivery tasks and operative tasks we do with the team. So that's why I'm just pointing out the collaboration as a very good thing about GitOps. And well, I think that's it. Thank you very much. And yeah, I hope this information helps you to improve your projects. Thank you.
Thank you, Juan. I couldn't agree more about the collaboration part. I think it's an important aspect about GitOps. I'm a big fan of GitOps, so love the presentation. And I hope everyone enjoyed it as much as I did. Be sure to leave your comments, questions for Juan on the chat as he will be responding there. Thank you all also again for this great session. Be sure to review our Devweek agenda on our official website and see you on the next one.
Thank you. See you.